हरिः कर्ता।
Now let's look into the vectors. So for that we need to work on the ix underscore function. The ix underscore function can be used to combine different vectors so as to combine the result for each n applet. Let's take one example. So this is ix function. Yeah. So let's take one example. If we want to compute a plus b times c, that's a vector. For example, we'll take three vectors, and if you want to compute that a plus b times c for all the triplets taken from each of the vectors a, b and c, so let's see how it comes. Let me take the first vector. A is equals to np dot array, and inside that I'm going to take my first vector using a sequence. That's a 2 comma 3 comma 4 comma 5. Okay, this is my first vector, and let me copy the same vector and do a slight modification for the second vector. So let me put my second vector as b, and this time I'm gonna go with the sequence of three elements. So 3 comma 8 comma 5 comma 4, and next time this is c. I'm gonna go with the name c, the vector name is c, and a sequence of 5 elements. So 5 4 6 8 and finally 3. So all three vectors are ready. So let me print all three vectors one by one. Print b and print c2. So it's very clear, it's all one dimensional. It's pretty clear. So now what I want is I want to compute a plus b times c. Okay, so let me do that. For that I need to calculate ax, bx, cx. So simply I can use a function called ix underscore to do this calculation. So ax, bx, cx, it's like a variable assignment, a tuple assignment. This is called variable tuple assignment. So then np, our array is getting ready, and ix underscore method I'm using, and then a comma b comma c, total 3 arrays. And let me click on ax and c. That's it, you got it. 2 comma 3 4 5, a multi-dimensional. So ax dot ndim, it's a 3-dimensional, and let me see the shape of this. Ax dot shape, it's a 4 1 of 1, 4 comma 1 comma 1. It's pretty clear, you can see it from the output itself. Then let me go for the bx and see what's going to happen. So bx is, it consists of just 3 elements, so that's the reason it got 3 matrices. It's again 3 dimension. It's a 3 comma 1 comma 1 is the shape of this bx. Now let me check for the cx. So cx, oh, nothing much changed because array cx has 5 elements, so it became a one dimension. So now ax dot shape and bx dot shape and cx dot shape, let's see how that it's look. And bx dot shape and cx dot shape. So 4 1 1 131 and 115. So these are all the shapes of different matrices. So now what I'm gonna do, so I'm gonna just calculate the result. That's ax plus bx plus cx and see what's going to happen. So now let me print a result. And here is that the response, the result. So now let me check the print, check the size of it. So the size of it, so let me result dot shape. It's 4 comma 3 comma 5, total 4 matrices, and each matrix 3 rows and 5 columns. So now I just want to do one more activity. It's a result of index it 3 comma 2 comma 4, and what you got is a 12. And another way of doing some calculations, a of 3 plus b of 2 times, sorry, let me come out of this. Yeah, a of 3 plus b of 2 times, I'll go with c of 4 and see what will be the value. It's 17, absolutely 17. So the result, so that's how we use the tool to do calculations. And similarly, you could even implement the reduce here. So to implement the reduce, just look at the following example. So let me take a function. Let me define a function. Def, the function name, I'm gonna give ufunc reduce, and the first parameter is ufct, and the second parameter uh, is vectors arbitrary. This one is arbitrary, and then colon, and let me do some calculations down. vsnp dot ix method and all parameters, arbitrary parameters, args, or you can say all arbitrary arguments. Then r is equals to ufct dot identity. So for loop values for v in vs, and return r is equals to ufct of r comma v, and let me return it. Return what I want to return r. That's it. Let me execute that. We have defined the function. So now how can we use it? If you just want to use this function, you can simply call the function. Now you say ufunc reduce, and inside that I'll say arrays np add. That's the first one, that's the function you have to mention. And then what you want to do is what it is mentioned as a first argument, and after that we will be attaching the arrays where the action should be taken place, a b c, and here is the result, here is the calculation. So this is another way of doing the same activity, but this is using the function. So the advantage of the second version is the advantage of this version of reduce compared to the normal ufunc.reduce is that it makes the use of the broadcasting rules in order to avoid creating an argument arrays the size of the output times the number of vectors.